here, eternal voice, Sotero. So we need to have another problem relates to mass transfer. This is question number 4 or problem number 4. So take a look for 2 to 5 minutes again, and then by the end we will solve this together. You can get a blank sheet of paper also. Okay, this I presented already a while ago the basic formulas for this, right? Okay. So, okay, I will read now the problem. To avoid the pressure buildup of ammonia gas at atmospheric pressure, it is vented to absorption through a 3 millimeter inside diameter pipe, 20-meter length. Determine the mass of ammonia. Wow. Diffusivity of mass of air diffusing with 0.28 times 10 to the negative 4 meter per second square. Determine the mass of ammonia with a diffusivity of 0.28 times 10 to the 4 meters squared per second, diffusing in air. Oh, really? Ganon. Oh my gosh! So in here, the data are minimal. So the data are, so inside diameter is ID, ha? So 3 millimeter is our inside diameter. Okay, so we will write now. Oh no, first, what is being asked? Determine the mass of ammonia. Wow. Mass of ammonia. Meaning to say, guys, if you try to, to analyze this problem, it looks like this is not a mass transfer. It's only like a normal chemistry problem, regular in chemical calculations or stoichiometry topic. See? But the only problem here, it is being discussed absorption terms. Absorption and diffusivity. This is the identification already. If there is a diffusivity, it's already transport phenomena. The word diffusivity will indicate. Okay, so in momentum, okay, momentum diffusivity. Okay, in rate of heat transfer, we have the thermal conductivity, and then in the mass transfer, we have the mass diffusivity or diffusion coefficient. It's mentioned here, right? Diffusivity. So, oh my gosh, and diffusing. Oh, it's gonna be like that because it's diffusion. Diffusion is mass transfer already. Bingo. We can already troubleshoot, right? Get the point. Okay, because diffusion is not discussed very well in chemistry, right? General chemistry lecture. It is in the last part. It is being discussed together with quantum mechanics, the study of motion, interaction of elementary particles, neutron, electrons like that. Okay, it's there in the last part of the book. And who cares studying the last part of the book? Right? We have a very thick chemistry book. I remember that was written by the author Fred Moore. Orange color. That's very thick. And then imagine that's very thick and you go to the last part. Of course, it cannot be studied all. So the chance is our person, our instructions will go to the most important, major, and significant topics. Okay? But the other topics are only just like a supporting actor, a supporting actress to the movie actor or the movie actress, something like that. Okay? The analogy. So we'll just focus on the most substantial and important topics. Okay, that will always, comes out in future examinations like that. Okay? But for the other, for example, quantum mechanics, statistical mechanics, these things are not being discussed clearly in college. Okay? It is being touched only, but not in detail. Okay? Diffusion also not being discussed very well. Okay? But, they go directly to the, distillation, liquid extraction, something like that, flotation, screening, crystallization, evaporation, ganon, heat exchangers, ganon. But this, I remember also have, but not too much. Okay, the important thing is only we need to familiarize. Okay, if our instructors, our mentors giving only one problem, then bingo, and then the rest will be yours. Okay, it's gonna be like the rest will be yours. Okay, so you have to expound and you have to expand and you have to go outside the box. Okay, from the classroom instruction. Okay, you have the classroom instruction during your subjects, right? Hourly like that, and you have to go outside the box, meaning you will go to the library, you have to research, or it is enough, you go to the public library where there's a very good source of books there. Public library in your city, wherever, if you want to research more. But I think your university library will be enough. Okay, and then you will bring books in your home, study very well, investigate, and then di ka matug kung hindi mo makuha, yung ana ba? Okay? So that you will learn a lot. Okay? Because when I was in college before, I will be bothered if you cannot solve that one. Okay, I'll solve first, and then, well, I'm wrong, and then I'll go back to the problem like that. Okay, ganun. Then I have to put that in my brain cells, so that next time, the problem goes like that also, the way it is being solved like that, then I can remember and I can solve, okay, I can get it already. Okay, something like that. So that is practice problem solving. Practice makes perfect, something like that. Okay, but it's not enough only practice, you have to memorize. Okay, especially basic formulas and constants. Okay, you get the point? For example, only one basic example. What is the formula of a centripetal force? What is the formula of a centrifugal force? There's a lot of forces around us. Okay, we have the frictional force. Okay, we have the applied force. We have the impulse force. Force times time, right? Okay, and so many things. That's why we need to create the FBD diagram when we solve about forces, right? In physics, free body diagram, so that we can understand what forces going in, going out, acted on the perpendicular to the surface, like that. Okay, so we need to go back to the problem now. To determine the mass of H3, so if this is gonna be the case class, so it is flow rate, it is not mentioned that this is flux, it is only mass of ammonia. What you will do for this? Normally, you will think the general chemistry lecture, right? It's that molar mass. I don't have to put the given because very minimal given. Only few. Okay? So, I don't have to write, okay? So, minimum molar mass. Uy, numuagi akong kuan guys. Akong tantalpin, so I have to use another tantalpin. Okay? But this one, very new. Oh my gosh. My gosh, what's happening? What's happening? Oh my gosh, very fun. Okay? So I have to put the molar mass is equal to the mass over the number of moles. So if it is a single atom or single element, you have to consider atomic mass or atomic weight. Something like that. Oh my gosh, it's very easy to remove the plastic. What's happening? Oh my gosh. Right? Oh. Okay na. Guys, I've compiled a lot of videos and later I will be able to put descriptions and upload them on my channel and then baden relax for a while. Like that, right? So in short, namundo kong videos. Okay. So how gonna we do this? Oh my gosh. It's gonna be like this. Okay. So molar mass is equals to the mass over the number of moles. So since mass of ammonia, so it's gonna be mass of ammonia is equal to the molar mass or the molecular weight of ammonia. Okay. Molecular weight of ammonia times the number of moles. This one. So this is from chemistry. We will connect this to the mass transfer. Okay, so how can we connect? This is equation number 1. Now, it is very evident that we have the molecular weight of the, what's this? Ammonia? Oh, okay, ammonia. So it's gonna be around 17, based on my memorization, 17 grams per mole. Okay, correct me if I'm wrong. Okay, so we have the number of moles. So the number of moles of ammonia here. Okay, usually, I will give you technique. My gosh, asang takuban ni Uy? Kaloka. Okay, I will give you technique. Usually, if gases like ammonia, carbon dioxide, okay, carbon monoxide, nitrogen, oxygen, hydrogen, okay, so most of the times we will assume an ideal solution or an ideal gas. Okay, like that. That's a technique, especially if it involves gases, because mass transfers are not limited to gases. It's also applied in still solids and liquids. Okay, but since we know the fact these gases have a high diffusion rate, so sila yun ang maguna, something like that. Okay, light term na sila. Okay, so density is very less or light. Okay, so now in this equation, guys, na ang molecular weight or makakapag sa ammonia. So, sa unang pagkuha, how can you obtain the number of moles of ammonia? So, there's a lot, right? You can obtain that through PV and RT, and you can obtain that also to, let's say, concentration, right? Concentration is equals to the moles, okay, over liter. So, there is also N there. So, that's second option. Third option, you can get that number of moles through Avogadro number. Okay, constant. 6.023 times 10 to the 23 per mole. Because there's per mole here. And then if you multiply that with something, chuba, then cancel with the molecular weight, you can obtain the grams. So 3 option na siya, Avogadro number. Fourth option, how can you get the number of moles? Actually, fourth option will be through chemical reaction, balanced chemical reaction. But here, there's no chemical reaction involved because it is only ammonia passing to that particular, what's this? Pipe. Okay? So, chemical reaction is not possible here. Because stoichiometric, you can get the number of moles through that, right? So, it's very easy, supposedly. So, that is fourth option. Our last option will be the special one. Okay, the number of moles. Muna siya atong we give emphasis to this. The number of moles of ammonia, okay, is equal to the, because this involves diffusion, we can use this directly. I am choosing only the possible option to get the number of moles. Okay, so gi-maximize na ko ba when to get number of moles in a particular problem. If the problem will ask what is the number of moles of the certain substances. Okay, so we have 6 options to do that. But we need to consider the last option because it involves diffusion coefficient, in which under the topic of mass transfer. It's gonna be like that. It should not be limited to one, to one area. So moles of ammonia is equal to the diffusion coefficient of ammonia, so DNH3, right? DNH3 over, nakakaloka talaga ito, minimum resistance. Di ba guys? So, this is the thing I don't like with mass transfer. Okay, because resistance, it looks like very far from, from the topic, because the resistance usually involved in the electrical energy, right? Ohm's law, voltage is equals to current times resistance. But in here also, resistance will appear, right? It's due to the fact that when this ammonia will diffuse, there is a resisting force, what we call as a resistance, the resistance to flow. So this has been considered in mass transfer. But we are used to, as as a human being, as a student or as an examinee or as an ordinary citizen, something like that, then we are used to that when we talk about resistance, that all practical electricity. Okay, resistance under Ohm's law. That is the most popular, ideology for that or concept for that. Okay, so, there's also resistance here. Yes, there is. Okay, this is moles of ammonia is equals to diffusion coefficient or the mass diffusivity over the resistance of ammonia. Now, guys, in this mass transfer, the resistance referred here is minimum. Okay, why minimum? So you should put R min, meaning minimum. Why? Okay, because you don't have to put too much resistance or else your ammonia will not flow. Okay, in the pipe, so that is your purpose, to flow the ammonia on the certain, so that we can achieve the desired concentration in it, so that we can yield, productive, product or useful products, mass production, good mass production, and better quality of your products, of course. Then you need only small or minimum resistance. That's why it's specified. Minimum resistance, R min. This is the most important part, ha? Or else, if too much resistance, this will not flow. So, wala kay product. Okay, muna yung nahitabo nga minimum resistance siya pirmi ha sa transport phenomena. Okay, like that because pariram sa siya sa heat transfers na may nganay po. Okay, so R minimum. Okay. Now guys, nabiya kay diffusion coefficient. Atong target guys is to solve for the number of moles. So our last option is through using this formula. Number of moles of ammonia is equal to diffusion coefficient over the resistance. Now, you don't have also the value of resistance minimum directly. How can we compute that one? So we can use that by using the formula again. Common to all mass heat transfers, mass transfer, and the moment of transfer. We have resistance is equals to the length over the, okay, length over the diffusivity. Something like that. Or the K, right? Diffusivity or the K. K man ang diffusivity, no? K means constant, by the way. This is general. And then you can put that any. It could be diffusion coefficient, it could be thermal conductivity, and it could be also the dynamic viscosity in moment of transfer, right? Okay? It depends on the situation. But K here would be the diffusion coefficient, so meaning L over D and H3. Okay? So in here guys, two-step, right? Two-step pa siya? Yes, two steps in order we can have the number of moles. Now, so we have the diffusion coefficient of ammonia, but we don't have the resistance minimum of ammonia. Then we have the resistance minimum of ammonia by having the length, which is we have, right, over the diffusion coefficient that we have, so we can have the R minimum. So we can solve now the number of moles of ammonia times the molecular weight, and we have now the mass of ammonia, which is being asked in the problem. Okay, this is our first option. And we need to have another option later, okay? If we can get directly the correct answer, then no need to go to another option. Okay? So, muna nakaparat kay dagan mo ko siya mga formulas na related sa good siya. So, di ba? So, you have to be, you be, what do you call this one? Alert. Okay? So, muna siya. So, NH ammonia is equals to the diffusion coefficient ammonia 0.28 times 10 to the negative 4 square meter per second, okay, over R minimum. R minimum, okay, is equal to the length. Nabatay length. Ato basahan ang problem. It is vented to absorption through a 3 millimeter inches diameter, a 3 millimeter inside diameter, and 20 meter length. Na-share length. So 20 meter over 0.28. So bingo, we can have the resistance minimum. So times 10 to the negative 4. Okay, ganun siya. Take note guys ha, this is very interesting because the unit of the minimum resistance is also the unit of the speed and velocity. Nakakaloka, no? Okay, because our resistance in the practical electricity is ohms, right? But here is not ohms. Okay, get the point? So because it will move, right? It will resist the force. So it's also having the speed. That's why the unit is speed. So it can be, it can be logical to have the unit of meter per second also. Okay? So 20 divided by, nakakaloka, 20 divided by 0.28 exponent to the negative 4 is equal to, oh my gosh, R minimum is equal to 7.14285. We need to carry all the decimal points, but it matters a lot in the final answer. Right? 7.14285, so 1, 2, 3, 4, 5 times 10 to the negative 5. Really? Negative 5? 1, 2, 3, 4, 5. Yes. Negative 5. Because kung 5 siya, so 7.5 siya, 1, 2, 3, so times 10 to the positive 5. Okay? Not negative. Because if you move that to the right, 1, 2, 3, 4, 5, it will become 71,400. Wait. Okay, 714,285 if you move to the right. Okay, so 1, 2, 3, 4, 5. So times 10 to the 5. Not to the left. Okay? This is our R minimum. Okay, guys? Because anything will be divided by an exponential which is negative, your answer will be big. Right? That's theory, right? Okay, now. We have now the R minimum. Now, substitute here once again. So, 0.28 times 10 to the negative 4, okay, over 7.4285 times 10 to the 5. That is meter per second, right? Oh my gosh. Okay. Muna na siya mahitabo karon. Okay, divide mo ang kuan, 0.28 meter. Okay, so 0.28 exponent. Okay, negative 4 divided by 7.14285 exponent to the 5. So we have 3.92 exponent to the negative 11. This is your moles of ammonia. Wow! Very light. Negative 11. Wow, nakakaloka. Just like, no, what's that negative 11? Oh, it's lesser than the proton and the neutron, right? So times 10 to the negative 11. Okay? Muna yung NH ammonia. Okay, then substitute this to this equation. Okay, so molecular weight is equals to 3.92 times 10 to the 11. Okay, ganon. And then, okay, times molecular weight and then the number of moles. So, muna siya nahitabo. Ammonia, 17 grams per gram mole. So, and this will be this is mole also. But take note, guys, in here, meter squared, meter, cancel. Okay, it is still meter, right? So how can we convert that to mole? Patay. Okay, here. So you said, right, mole of ammonia is equals to the diffusivity over the minimum resistance in meter per second. Since you know that you have squared meter at the top, and then you cancel that out, what will be left is the meter only. And meter is the unit of length, not the unit of mole. How can you do this? And then since you are following only the formula, and you have to use that in your R minimum, then when you get that here, diba? Meter, ibutang mo sa tumoy, may mo siyang meter per second ay mong R minimum. Okay, muna siya. Okay, got the point? Muna yung R minimum, meter per second. Ibalik mo siya dito solve. Okay, mahimo siyang kuan. Meter per second. Meter na lang siya. Right? So, that is not the correct unit of the number of moles. How can you do this? Okay? So, this is our option 1. Our option 1 is, it looks like very complex when in terms of units cancellation. This is it. Okay. This is the disadvantage of solving on the spot. Okay. So, moles of ammonia is equal to the diffusion coefficient over the R minimum. So, we have 0.28 times centimeter per second. R minimum for ganun siya to chuchok. Okay. 20 meter mo na siya. Perfect yun siya. So, M, cancel. So, meter per second, ilagay siya. Okay, ang R minimum niya. So, in that way, we have a unit of meter for the ammonia. It is not correct. So assume this as equation 1. Okay, and look for other possibilities later. Now, we go to option 2. I just make myself difficult in which I have to look first. Okay, and then I can solve perfectly if I have to look first, right? But I'll never look how it is being solved. That's why it's gonna be like this. Okay, so option number 2. How can we do this? So we need to use the mass flux. MA over A. Okay, is equal to the diffusion coefficient DAB. Okay, delta change in concentration over the delta change in the length. Okay, this one. So the only problem here, guys, is we don't have also a value of concentration. Here. How can we do this? We don't have a value of concentration. So this will not hold through also. Then we can correlate this also to ideal gas law because this is ammonia, right? Okay, no problem. This is equation 3. Okay. So after correlating before, yes, a while ago, so yung mulit so na kung ako man na-memorize ganina pag-read. So we have Na is equals to negative DAB. Okay. Area, pressure 2 minus pressure 1 over RPL. This is equation 3. Equation 1, equation 2, equation 3. Our equation 1 is far from reality. Our equation 2, it's still okay, but we don't have concentration. Our equation number 3, will be appropriate because it's dealing with ideal gas law. But let's see also. Okay. So let's use this equation number 3. Try. Okay. Na is equal to diffusion coefficient 0.28 times 10 to the negative 4 meters squared per second times the area, area is equal to pi d squared 4. Pi d squared over 4 is just equal to pi r squared, ha? Since ang given diameter, so we'll need to use the pi d squared over 4. It's just the same raman good siya. So pi d squared over 4, so we have 3 millimeter, convert to meter. How much? Divided by 1,000, right? So divided by 1,000. So, oh my gosh, 0.003. 1, 2, 3, okay. Squared over 4. And the unit for this, guys, is meter squared. Okay. And then the pressure 2. It's mentioned here to avoid the pressure buildup of ammonia gas atmospheric pressure. Oh. So there's an atmospheric pressure, so there's already 1. But there's no initial pressure here. To avoid the pressure build, no, there's no final pressure here. He said, man, to avoid the pressure build up. So we need to avoid the pressure build up, meaning the pressure at the final are being avoided, right? Gas at atmospheric pressure, meaning there is an existing pressure which is an atmospheric pressure. So our pressure 1 is having value. So we have 1 atmosphere. Rest. 1 atmosphere. Kaya naman siya, to avoid the pressure buildup of ammonia gas at atmospheric pressure, meaning the existing pressure is in atmospheric value, meaning 1 atmosphere. So this is our P1. And then our P2, which is, we try to avoid that one, to avoid pressure buildup, so we don't have pressure at the final. So meaning to say, our pressure in the final is 0. Right? And there's no also pressure mentioned here in the problem. I think so. Okay, so let's try this option number 3. Anyway, we can have another option to solve this, okay? So pressure number 2 is 0. Okay, and then since I use 1 atmosphere, it will not be similar to the other units. I will use Pascal. Right, so convert 1 atmosphere to Pascal, it is still again 101,325. So 101,325. Pascal is equivalent to Newton per square meter. Newton square meter. Then over universal gas constant, in which I memorized already. I derived that already also. Let's check. So 8.3145. Let's try only because if it's not possible, then we will not force this. We will find another. Okay, so 83.145 cubic meter. Yes, it's agreeing. Cubic meter, right? Cubic meter. Now, Pascal also agree. Okay, Pascal over mole Kelvin. And then times the temperature. Mention ba ang temperature din here? To avoid the pressure buildup of ammonia gas at atmospheric pressure, it is vented to absorption through a 3 mm inch diameter. Mo ni siya nakakuan sa high. Because there's no given temperature. Na imo na sad na siya i-assume na ideal, in which try na sa temperature na 273. Diba? So mo na siya nakalisod usahay kay usahay mo given, usahay mo wala. And then it makes us confused sometimes. Really, what do you kung ano ni maayo? Okay? Even though mga manya cum laude, so mga cum laude, we will be also confused sometimes for this. Okay? Sure, 100%. Okay? Because here, we assume, in the first place, we assume only, right? It is not confirmed. We assume only that this is an ideal. And then there's no also temperature given. And sometimes also, we assume an ideal, the temperature is also there. Right? You get the point? And then we need to use the temperature that is given, not the temperature in the ideal. So here, we don't have the given temperature. We have the temperature in an ideal, which is a 273. Then we will force to use the 273. We have no choice, right? You got the point? Things like this, we have to analyze. Okay, we have no choice because there's no given temperature in the problem. So we need to use the 273 Kelvin. Anyway, this is part of we assume that this is an ideal. Okay, so this is 273. Okay, we investigated one by one. That's why 215 Kelvin. Okay, and then visualization of the unit. Cancellation, K cancels. Oh, bongga. Pascal cancel. My gosh. Cubic meter also cancel. So meter per second left here, right? Meter will be left here, and then mole will be left here. Okay, and there is still second at the numerator. Nakakaloka. So, like this. Ano? It's in the denominator. Yes, ako ba? Anjub ko. Okay, so meter per second or meter per moles, cancel. Bingo! This is mole per second. Okay, mole per second is the unit of molar flux or the molar flow rate. And what is being asked in the problem? Mass pa siya. Okay, determine the mass of ammonia diffusivity. Okay, oh my gosh. So we need to multiply this by, or no, divide this by the molecular weight of ammonia later. Okay, so equation number 3 is the correct equations that we'll be able to use. Okay, things like this, huh? Okay, so 273, okay, 273.15 times 8.3145 is equal to 2271.105675, and then take note guys, the pressure here is negative, right? And there's also negative in the diffusion coefficient, so positive siya. So it's logical, right? So sakto ang atong mga declaration. So 0.003 divided by 4, ganun siya, times 3. This squared ra ba siya? Pi, this squared, ang diameter ay squared, sorry. So 0.003, okay, divide times 3.1416 divided by 4. Okay, this is gonna be the answer. Times, okay, 0.28 exponential to the negative 4. Times, okay, negative 101.325 is equals to positive. Yes, this is positive, right? Positive ni siya. So, divided by 2271.10565, we have 7.88. Guys, you should take note, because if we refer to the mole per second or the molar flux, okay, or the molar flow rate, the value is very high exponent. Okay, always. Okay, 7.88 times 10 to the negative 9. So this is mole per second. Now we need to divide this by the molecular weight of ammonia, which is 17. 17, multiply siya, grams per mole, sorry. It depends on the situation, as long as it will be cancelled. This is conversion factor. If we try to multiply to divide, as long as it will cancel one of the units there, and that's the correct. So that's why I don't like conversion factor. I will use the proper formula if there is available. But in here, you need to direct manggod siya para dito na siya. Okay? You got the point? So mole, so this is become grams per second. Gram per second is a mass flow rate, okay, or mass flux, okay, or the mass diffusive flux or mass diffusion rate because it talks about diffusion here. There's a lot of terms to be asked in the same manner. Sometimes you'll be asked, determine the mass flux of ammonia. And then you'll be confused, what's flux? Ipugos dito ni mo pasok ang flux is equals to rate of mass transfer over, mayabuda yun ka, kaya puno na may sa imong formula dito. So it's only the term. Determine the mass flux of ammonia, determine the mass flow rate of ammonia, determine the mass diffusive flux of ammonia, determine the mass flow rate of ammonia, like this, okay? So that's the, as you kalibog na mga term, then it is just the same, okay? Like that, as long as there's mass, okay? Here there's no rate mentioned, but that is still being as the same, okay? Like that. So 9 times 17. Ako mag-memorize ang molecular weight sa ammonia, 17 siya. But double check that in Google search. Maybe it's wrong. Okay, because I don't have periodic table in my hand. Okay, so I cannot check in the periodic table. Okay, and I don't have time also to go to the Google search. Okay, I don't have, it take time only to, ammonia, kapuyan ko ba? Okay, so I need to memorize. Okay, ganun siya. So, our answer will be 1.34 times 10 to the negative 7 mass of ammonia, mass flux of ammonia. Okay, or mass flow rate of ammonia. Okay, so the unit will tell everything. Okay, this is gram per second. Okay, second, the rate at the denominator, and gram, mass. Okay, so it could be mass flow rate, mass flux, ganon, okay? Mass diffusive flux, mass diffusion rate, ganon. So, irambol-rambol na, wala ko pakialam sa mga na siya, gram per second. Okay? So, 1.34. 1.34 times 10 to the negative 7 mass of the ammonia. Let's check the answer. This is not coming from the board exam. Okay, this is sample problem. Okay. Okay. Okay, correct. The answer is correct. Almost near 1.32 something, and we have 1.34. At least, right? Okay. Only point something. So, yun sa siguro kayo stick to pa, di ba? So, I get 1.34 times the negative 7, but the answer is 1.323, ganun siya, times negative 7. No, it doesn't matter, right? Okay? As long as close rin guys siya. Okay? But if very far, then I have to rework the solution. It's correct. We use this equation. Equation number 3 in our last option. Okay, guys? Any questions so far for this particular problem? Okay, so thank you so much. You can comment down below in the comment section, and if you're not subscribing at my YT channel, then you can subscribe and you can click the notification bell for some newest updates. I will be here. Eternal voice. Bye bye, God bless everybody. See you later. Oh my gosh, talaga. Huy, tagal na upload.